Troubleshooting a 5-wire overfill prevention system.
Hi, I'm Brad Steffens. I'm the Product Reliability Leader with Civacon. Today we're going to discuss with you the 5-wire overfill system and ways to troubleshoot some common problems found with these. Before we get started, make sure you have your proper manual with you for these type of systems. They can be found on our website at civacon.com. Some of the tools that we will be using today to try to troubleshoot these problems and correct them are a quality pair of wire crimpers, cable stripper, wire stripper, side cutters, wrench, screwdriver, multimeter, any kind of API tester. Today we're going to be using the OPW 1397E and of course safety glasses. Notice on the system we're working with here, the 5-wire system, there's no onboard monitor on this like in the 2-wire. On a 2-wire, you typically have an onboard monitor that helps you troubleshoot the system and the faults that are with it. On the typical 5-wire, like we're dealing with now, it only has a blue socket or the optic socket. The only way to effectively troubleshoot this is with some sort of tester, like the one we showed previous in the film. The way that a 5-wire system is wired is the red, black, and green wires are all wired in parallel. When the yellow wire reaches the number 1 probe housing, it is connected with the yellow wire of number 1 sensor. The orange wire coming out of number 1 sensor then hooks to the yellow wire of number 2 sensor. The orange of number 2 goes to the yellow of number 3, and this continues until you hit the last compartment of the unit. The last sensor in the trailer or tank, whatever the case may be, returns back down to the socket. Okay, if you've been in a loading rack and receive a non-permit state at the rack, you'll need to go to a repair shop. When you get to the shop, you'll need to power up the system so you can troubleshoot what the issue may be. Today we'll use the OPW tester to power up the system to see what the state of it is. When the tester is connected, the green LED will be flashing if the trailer is showing permit. It'll flash the number of flashes that it has is in relation to the number of probes that the unit has. Now you'll see our tester in a non-permit state. The LED light is flashing twice. We broke the signal in our demonstration here between probes number 2 and 3. So it's showing that number 2 sensor is the probable cause of the failure. Okay, with our truck tester hooked up, it's showing us that number 2 sensor is potentially the issue with our system. That's telling us that number 1 probe is fine. The issue could either be with a wet sensor or a wiring issue, and the wiring issue doesn't exactly have to be in this number 2 housing. Remember, the wiring also goes in, it starts at the rear, goes in number 4 in this display here that has 4 compartments. It'll come in number 4, it'll connect to number 3, and then to number 2. So any one of these points could potentially be the wiring issue. In that situation, a less likely culprit would be the wiring between number 1 and 2 probes, which in that case, it would have to be the orange wire. The first step you want to do is to ensure that the probe is dry on the end of the prism. Just take a dry, clean rag, wipe it off, and see if that clears out your faults at your tester. Now, if you've determined that the probe is essentially dry and it's still showing it in a fault state, you'll need to start inspecting your wire connections. Start by removing the housing cap on the problematic probe. Be sure to check all crimp connections for being properly crimped and being free from corrosion. As you can see, these are free from corrosion for our demonstration. Give each connection a pull test to make sure they're crimped properly. Like that one right there that was easily removed, it appeared to be crimped, but they pull apart and that could be causing your fault. Also pay close attention to where the outer cabling is stripped off of each wire where it goes through the strain relief fittings. This also at each probe housing and at the socket itself. If the outer casing is improperly stripped, the inner wires can be nicked, allowing a place for moisture to get in and corrosion to form. If you've verified that all connections are free of corrosion and that the crimps are properly secured, you can check the voltage at the probe that is showing the fault. Simply connect your voltmeter into the red and black wire. The reading should be anywhere between 8 and 24 volts. At this point, if you verify that all the crimp connections are secure and free of corrosion, and they have the proper voltage at the probe that is showing the fault, now you would replace it with a new probe to see if that cures the problem. Now if you've replaced the probe in number 2 housing and the problem still persists, rewire in the original probe into that housing and move on to number 1 and install the new probe there. If that cures your problem, go ahead and reinstall the probe housings and your repairs are complete. If you've completed inspecting all the probe housing connections and replaced the probe and you continue to have issues, you'll now move down to the socket. To inspect the socket housing, remove the faceplate and verify that all the connections are properly crimped and free from corrosion. That completes the troubleshooting of 2 issues that are commonly found on a 5-wire overfill system: wiring problems and a defective probe. A third problem that is commonly found is in the grounding circuit. That can be determined if your tester shows that there's a fault in the ground system. We have an extensive video on this at Civacon.com that explains how to troubleshoot the ground circuit. This concludes our troubleshooting of the 5-wire overfill systems and the 3 issues that are most commonly found. If more support is needed, please refer to Civacon.com or contact our 1-800 tech line.